Hello, my name is Chad Barney, and I'm an application engineer here at PLM Solutions. I'd like to welcome you to another session of NX CAM Lunch Bytes. Today we're going to look at feature-based machining in NX CAM. We have several of you on the line with us today, so you'll be in listen-only mode for this session. If you have any questions after this session, you can email those to me at chad.varney@liplm.com. I want to remind you that we have all of our Lunch Bytes replays available on our website, and you can check those out at www.liplm.com. We also have a section where you can give us your suggestions for future Lunch Bytes topics. Today we're going to take a look at feature-based machining in NX CAM. First, we're going to look at the question, what is feature-based machining, and how is it different than regular programming in NX CAM? Then we're going to look at a part that has a variety of different features, and then use feature-based machining to create all the manufacturing operations. Then we're going to take a look at how PMI affects feature-based machining. We'll apply PMI dimensions and see how NX uses the PMI dimensions to select the proper tools and operations for that particular feature. Then we'll look at tagging holes for parts that weren't originally created in NX or imported geometry or an imported model. Then we'll look at a part that has a cylindrical face and it has features around the outside of that cylindrical face. We'll look at setting up our MCS so that NX can machine the features using feature-based machining. So what is feature-based machining? Feature-based machining is machining features of a model based on processes that are defined in the machining knowledge library. A traditional approach would be to create a tool, which includes all of your tool and tool holder parameters such as diameter, flute length, etc. Then create an operation that includes many other machining parameters such as depth of cut, step over, cut direction, things like that. Then you would repeat this process if the feature requires more than one operation, such as a counterbore hole, where you'd have three different operations. You'd have a center drill, and a co-bore. With feature-based machining, you search for your machinable features. Then NX will create a feature process based on process information in the machining knowledge library. So NX will select your tools, tool parameters, as well as your operations and operation parameters needed to machine the feature. So let's take a look. The first part I have here is just a plate with many different features. You can see this was modeled in NX. We have threaded holes in this part. These are symbolic threads here. We have some co-bore shapes. Then we have some pockets that are through. Then we also have some keyway slots as well. This is a perfect part for feature-based machining. These type of features are really good features to use feature-based machining. So what we're going to do is take a look at using feature-based machining, just kind of an overview of how feature-based machining works on this part. And then after that, we're going to take a deeper dive into some of the things we just talked about, some of the more specific details of feature-based machining. So this is just kind of to get an overview on this first part. Just going to create a new manufacturing setup. Going to define my part in the blank. Now I'm going to use my machining feature navigator. Just going to click on the tab, So I want to use this plate, the component here. I want to recognize features on that component. So what I like to do is right-click on that component and find features. Another option we have is, if you notice, we have a feature-based machining toolbar. Okay, we could use the Find Features button on the toolbar. Either way, basically gets you to the same place. So I'm just going to do Find Features. Now what you'll notice is we have a few different types. Feature identification is good for a model that is an NX model and you want to recognize NX features. I typically always use parametric feature or parametric recognition. That's really the preferred type, just in case your model isn't coming from NX. This still will recognize features on imported geometry. We've already selected our geometry because we right-clicked on the plate or on the component. So that's where it's searching for features at with this component. We have different options that we could select for which features to recognize. There's a lot of different options that we have here. For example, I've got this unchecked, which is turning. There's no turning on this part. Surfaces, we don't want to do any planar milling on this part, so I've unchecked surfaces. So you could set these up based on what type of features you want to recognize. I'm just going to simply select Find Features. Okay, it's found 42 features. All right, we notice that it puts a coordinate system on each feature. So we can kind of look and see each feature. And then we also notice that it has a machining direction. Has kind of an axis pointing down, so it's good to check those and make sure that those are pointing in the right direction, pointing down in your machining direction. If you don't want to see all of those coordinate systems, simply just right-click and turn those off. So now what I'm going to do is I like to toggle through these just to kind of see each feature. I just clicked on the feature and then I'm using my down arrow to toggle through each feature. And you'll see that the features in the graphics window highlight in orange. So you could toggle through those. These aren't in any particular order yet, however they will be after we create our feature process. So I like to kind of toggle through those and make sure that we've machined all of or recognized all of the features that we wanted to. And then what I'm going to do is I'm going to highlight all of these just simply by holding the Shift button in. And then again, I can do Create a Feature Process with a toolbar, or just right-click, Create Feature Process. We're going to use the mill drill machining knowledge library. We're not doing turning or wire EDM in this demonstration, so we're going to select mill drill each time. So what this is going to do is create feature processes, create our machining processes for each particular feature. It's going to select our tools and our operations for each particular feature. Now I'm going to go to the Operation Navigator. I'm in my geometry view. And notice now we have feature groups. You see that it's grouped these rectangular through pockets. We have our keyway slots grouped, our threaded holes, code board holes on the outside, and then the smaller code board holes. If we expand this, we'll notice that each feature has operations attached to it. So each feature has operations that the machining knowledge library has recommended or selected for each particular feature. So this whole feature is using a spot drill, and tap. We'll take a look at our machining tool view. Notice we have tools selected out of the tool library, and then operations selected under each tool. In our program order view, we notice that it puts our operations in the unused items. So we just need to drag those operations into our program, which is the default program is 1, 2, 3, 4. So let's drag those into that. And now we're ready to generate our operations. So we're going to generate each operation. One thing we notice is I've got my tool change column turned on. We notice that there's a tool change on every operation. Okay, that's maybe not exactly what we want. We're going to look at here in just a minute, how can we optimize this program so that we don't have as many tool changes. For example, we see we have 1, 2, 3 different spot drill operations. These operations are using the same spot drill, but they're in just different locations throughout the program, so you get a tool change every time. So we'll take a look at optimizing this program. We'll go ahead and show this through verification so we can kind of take a look at graphically how these operations look. So we do a rough milling on the holes, the through holes. And then we cut those through pockets. Something to keep in mind as well is if these are not the exact operations that you want, you can always modify each operation or add an operation. Let's say you want to add in different operations, no problem. But this is a great starting point. So we've drilled. Now it's tapping the threaded holes. Now we're spot drilling and then now drilling through. It's a pilot drill, and then this is the final through shape. And then co-boring these outer co-bored holes. Boring operation. Then it did the co-bore shape. Then the through holes, and then the counterbore holes. So you can see with feature-based machining, it machined this part pretty complete. And again, like I said, you can add or take away programs if this isn't exactly how you want it. You can always add things later or change parameters inside the operations. So let's take a look at minimizing our tool changes in this program. I'm just going to right-click, go to Object, and Optimize. What I want to do is just consolidate tools and minimize tool changes. So you'll see the operations, the order of these operations change. All right, so take a look at our tool change column. Now we notice there's not a tool change here. We've got a spot drill operation, then another one, and then the third one, but no tool changes. And we also have, in this drilling operation, uses the same drill here as it does with the next operation, so no tool change needed. So just kind of a way to optimize or minimize the amount of tool changes that you have. All right, now we're going to take a look at another part. It's actually the same part, but it has PMI dimensions applied. So we're going to take a look at how these PMI dimensions will affect feature-based machining. Let's take a closer look at these. These 3 holes basically have a tolerance added. It's got a plus 0.05 minus 0 tolerance. Okay, now notice the lower holes, the lower 3 holes do not. So these upper holes do have a tolerance. So let's go back and get started in feature-based machining again. I'm just going to do another general setup. In the same way, I'm going to define my part and blank. All right, so now we're ready to get started with feature-based machining. I'm going to find features. I'm going to hide my coordinate systems. Now if we take a look through the list, this is different than what we saw before. Notice we have a hole dimension underneath this hole. Okay, so this has PMI dimensions basically attached to this feature. We can look at that in the details and notice we have an upper tolerance and a lower. Okay, so there is 3 features that have hole dimensions attached. That's getting that from the PMI dimension that we had in our original model. So let's take a look at how that affects our machining operations. I'm going to go back to the Operation Navigator and the Geometry view. We notice this feature group has not changed. Neither is that one. Threaded holes didn't change, and neither did these co-board holes. And then these outside larger co-board holes didn't change either. Now we take a look, and we have 2 different groups now. So notice this group, if I open this up, we look at the operations, we have a spot drill, drill, and counterbore. We look at the next group, these are the 3 holes that had the PMI dimensions added. Notice we have a spot drill, drill, and a ream, and then a counterbore operation. So that's the difference, is the reaming operation. Since this is a more highly toleranced hole, we added a reaming operation. Feature-based machining selects a reaming operation for that. So a good way to use PMI data in feature-based machining. Next, we're going to take a look at a part that's actually just a parasolid. So this doesn't have any model history at all. As you can see over on the left, we don't have any model history or a history tree. This is just a solid. So there's no thread features or anything attached to this model. Okay, so there's no symbolic threads. But what I want to do is I want to tap these holes. So these holes that are just plain through holes, I want to actually what we call tag these holes to be a threaded hole, and then use feature-based machining to create our operations, including tapping. So I'm just going to go to a new manufacturing setup again. I'm going to define my part and the blank. Now in my machining feature navigator, I'm going to simply right click and find features, and let's take a look at what we get. Okay, we found 11 features in this part. If we look, this just says step hole. It does not say threaded hole, obviously because there's no thread feature at this point. So this is just going to do a simple spot drill and drill operation. And then we have these pocket shapes as well. Right, so there's no thread operation. All right, so I'm going to go ahead and delete these. So what I want to do is tag the faces of these holes so that they're a M6 tap. I want to tap these at an M6, so I'm just going to simply tag faces. I'm going to select each hole. Okay, now I want those to be threaded simple hole, and I want those to be an M6. And then I'm going to change the default depth. This plate is 10 millimeters thick. I'm going to change the depth to be 15. These are through holes. I want the drill and the tap operation to go about 5 millimeters past. So I'm just going to change the depth to 15. So now what you see is we have a threaded simple hole feature now for each of these holes. So now what we can do is take those, create a feature process, and take a look at the operations we get. We get a spot drill, and a tap operation. Go ahead and generate those. So we do a spot drill, and then we run our tap operation. Again, this is great for imported geometry or data that doesn't have features or threaded holes, things like that. You can actually tag faces so that feature-based machining will recognize those faces that you want to machine. Right, the last part that I want to look at is a cylindrical part. Notice we have features on the top side of this, and then we also have features going all the way around the outside of this shape. So if you want to use feature-based machining on these features on the outside of this cylindrical face, there's a couple extra steps that we'll need to do, so we'll take a look at that. In manufacturing, I'm going to go ahead and leave my MCS alone right now. We'll actually make some changes to that in a minute. I'm going to specify my part. I'm going to specify the blank using a bounding cylinder along this vector. All right, and then we'll take a look at finding our features. All right, so the features that it's found, if we toggle through these, we see that it found those codeboard holes on the top, and then these threaded holes on the side. You can see them highlighting in orange. All right, what I actually want to do is I want to cut these outer holes using like a horizontal mill. So I want to machine them in this direction. I don't want to do these holes. I just want to do the holes on the outside of this cylindrical face. Okay, so I'm just going to go ahead and delete these features now. So what I'm going to do next is actually what I'm going to do is I'm going to change my MCS. Notice my MCS is pointing in the Z direction. So I need to actually make a change to that. I'm going to be machining pointing toward this cylindrical face. So I'm just going to take my MCS and I'm just going to rotate it 90 degrees. So now we see our Z-axis is pointing towards those holes, or pointing towards the outside of this part. All right, so we're going to go and find features again. Now there's some ways that you can limit what features that you find. Okay, one of the ways to do that is you can tell it the machining axis direction. I want to tell it to machine towards an axis. You can specify a vector away from a point, to a point, away from an axis, or toward an axis. I want to machine the holes that are facing toward an axis. Okay, I could pick this graphically out here on the screen, or I could have used the drop-down menu. I'm going to go ahead and I pick that vertical axis pointing towards the center of the part, basically. You can see it highlighted in yellow here. So now I'm going to find the features that are in that machining direction. Now notice we only found 10 features. These 10 features are just the holes on the outside of the part. We do not have these features selected now. So let's take a look at creating a feature process for these holes on the outside. All right, notice we get a warning. Create feature process succeeded with warnings. Okay, we can show an information window. Okay, so this lists details about each feature. And then if we come down to the bottom of this, we can actually get a little bit more information. We see that a feature, or these features here, are filtered out. And then we also notice it says access direction does not match with MCS of selected geometry group. Okay, so there's an issue with our MCS. So we're going to take a look at what that is and how to fix that. So let's go to our operation navigator and look at see what we have. What we have right now is a feature group, but it only has one feature in it. See it highlighted in red there. Okay, this is because our tool axis is set to Z. Okay, our tool axis is set to Z, but since this is going to be like on a horizontal mill, we're going to be able to rotate this part around to drill each of these holes. But unfortunately, the default settings aren't allowing us to do that because our tool axis is set to Z only. It's only allowed to move in this direction. Okay, so how we fix that, if we take a look at our MCS mill dialog, we need to find an option that is called mill axis, and it's actually not in here by default. So all we need to do is customize this dialog. So that's what we're going to do. I'm just going to right click, Object, and Customize. Notice we can add tool axis to that dialog. So just simply select tool axis and add that to a dialog. Okay, notice it adds it right at the very beginning. Okay, that's fine. We can move that up or down if we needed to. I'm just going to add it to the very beginning. Now if we take a look at our MCS mill, notice we have the tool axis option. And like I said before, it's set to Z. Okay, what we need to do is we need to set this to all axis. Go ahead and accept that. Now back into our machining feature navigator. I'm going to select these features again and now create a feature process. Notice no warning this time. Now notice all of these holes on the outside cylindrical face are highlighted in red, which means it has these machining features recognized, and it created a feature process for each of these holes on the outside. Okay, so that's looking a lot better. So we can go ahead and verify this. In verification, it shows the tool moving around the outside of the part. After this was post-processed, it would actually be the part rotating instead of the tool rotating. So that's just how the verification works. So now it's drilling those holes. And now doing a tapping operation. Well, that's all I have for this session of NX Lunch Bytes. I want to thank you for attending. I hope that this was valuable to you. I know many of you may not be familiar with feature-based machining, so hopefully this kind of gave you a good overview. And then some of you that are more familiar with feature-based machining, hopefully you were able to pick up on some tips and tricks, specifically like on that last part there, how to do holes on a cylindrical face. If you have any questions about this Lunch Byte session, please email those to me at chad.varney@alliplm.com. I also want to encourage you to go to our website at www.alliplm.com. Check out our current promotions. You just go to the Events tab and then Current Promotions, and it'll bring up all of our current promotions. I want to thank you for joining us. Hope you have a great day.